Hello. Now, sorry, not the best way to start a video by slowly dying. Okay, but this is kind of it's not necessarily a topic video on its own as such, but it's something that's not necessarily mentioned in the specification. Now, we will obviously be doing a specification video for C4, but this particular instance, okay, it's just something that you need to be aware of. And to be honest, I think it's only ever cropped up in one exam. And to be honest, that particular question was really, really nasty. And I think I definitely will be doing it as a past paper, okay, at some point. But in case I don't, I just want to point this out. Now, the sine curve and the cosine curve. Now, if you were to draw them, or you can look them up, you will notice that they are the same curve. In other words, they both have a maximum height of 1 and a minimum height of -1. Okay? And they both follow the same pattern. In other words, if you can think of it, their wavelength, if you could call them waves, as the respective of having a wavelength, okay, obviously in terms of degrees, what I'm trying to get across is they're the same, but they're shifted by a different amount. Okay, so the cos graph, okay, so I'll just draw a quick sketch of them, actually. Yeah, get the graph right, so that's minus and plus, so that's -1 and +1, okay. So I'll draw the cos graph in red, okay. Obviously you can, just have a go at this yourself, but if you're not 100%, where does the cos graph start, where does it end? Obviously what you can do is simply just do the standard thing of doing, obviously you know what to do, but can't bother trying to explain it. So you can do the cos of 0, what does that come out to? So you've got to start the cos graph at the top at 1, and then just do each one. Obviously it's going to be 90, 180, 270, etc, etc. Alright, so just try and model it that way. If you can't, remember it like I can't, like that, the actual graph, okay? But as I say, cos 0 is 1, okay? So therefore cos 90 is 0. So you follow that trend, okay? So therefore obviously cos of 180 is your next point that you mentioned, and that's -1. Actually, I probably should have, I'll just pause the video actually, and I'll draw the graphs because I'll probably waste a few bits of your time. Sorry. So I've drawn the graphs here. Okay, so obviously in blue, as I mentioned, we've got the sine graph, and we've got the cos graph in red. Okay, now this is just a simple sine x and cos x graph. They've not been stretched in any way or moved at all. That is pure and simple what they look like. Now you can see, as I say, they look exactly the same. That's because obviously they are. Now the key thing to distinguish here is that the cos graph, okay, or whichever way you want to word it, the sine graph is shifted to the right by 90 degrees. In other words, if we were to write this as a transformation, okay, so ignore the fact that these are two different curves. Ignore the fact that these are a sine graph and a cos graph. If we were to go back even as far back as C1 and say, let's call these both graphs f of x, okay? So let's call the sine graph, okay, we'll call that f of x. We'll call the cos graph g of x, okay? I'm only doing this so it doesn't appear stupid, okay? Or it might confuse you even more. What I'm trying to hint at here is the fact that the sine graph is shifted to the right. Sorry, the cos graph is shifted to the right by 90 degrees to get the sine graph, okay? So you can either write this in terms of f of x or g of x. I'll write it in terms of sine and cos, okay, first, and then if you don't get that, I'll write it as f of x and g of x respectively. Okay, so as I say, the sine graph is a cos graph shifted to the right by 90 degrees. Okay, so if we wanted the sine graph, so we write sine of x, so that graph, okay, is the cos graph shifted to the right. So it's cos, now it's not just cos of x, we're not saying sine of x is equal to cos of x, because it quite clearly isn't. what we're saying here is the cos graph, the sine graph is the cos graph shifted to the right. And we represent a shifted to the right as x minus 90. Okay, so that is a key relationship you need to be aware of. And obviously if you don't get it in terms of f of x and g of x, f of x is the same, relates to the same sine x, and cos x is the same as saying g of x. So it's f of x is to g of x, take 90. So they both mean the same thing, but I just wrote them slightly differently. But this is the key principle here. Now you may be going, how the hell do we apply this to any sort of question apart from a question that asks about the comparison between a sine curve and a cos curve? Well, good question. You're full of these good questions. Now, the question I'm relating to here required you to know that sine 40 was the same as saying cos 50, and the same as, and cos 40 was the same as saying sine 50. Now, what am I trying to hint at here? There's no other way to put it. I've tried to build it up to as much as I can. These two should equal 90 degrees. In other words, this angle here, the sine of an angle, and the cos of another angle, they must both total to 90 degrees. Okay? In other words, if we want a sine value, so sine of something is equal to cos of something else, if them two somethings add up to 90 degrees, they will give the same value. And you can try this for absolutely any value that you want. Okay? As long as they add up to 90 degrees, they will be the same. Now, it's already on me saying that, but I think a good demonstration is in order. Okay? Now, how does this relate to the curves? I can't really explain that because, well, it's a simple relationship, but I can't explain in the words I don't really know. So, why have I shown you that? That's just to highlight the fact that they're a shift of each other. Okay? So therefore, if they both add up to 90, they will be the same. In other words, what this is trying to show, okay, in relation to the curves, if we said, right, we've picked, say let's pick 90 degrees, okay? So if we do cos, if we input x as 90 degrees for both sine and cos, let's see what we get. Well, for the cos graph, we get 0. And you can put that in your calculator, cos 90, you get 0. But the sine graph, when we do sine of 90, we get positive 1. Now, if we apply this theory that they both have to add up to 90 degrees, okay, in other words, they're a shift of each other of 90 degrees. So if we say, right, actually this isn't such a good example, it's just showing you a shift of 90 degrees, okay, which you already know. Yeah, that's not going to work. Right, just go with the theory that they add up to 90 degrees. Okay? If they add up to 90 degrees, it will give the same value. Right. Hopefully I've tried to... I'm sorry if I confused you in the last little bit there. Right. I'll just go through a few examples to see prove this is true, but obviously you can as well. Well, let's use my hand. Okay, so let's pick the values 45 and 45. So, let's do the sine of 45. If you want to do that in your calculator, get a value, whatever that value may be. Work out the value for cos 45. You should get exactly the same answer. And you go, well, why is that? Because if we look on the graph, oh look, that's where they intersect. So they will give the same value. And that's because they add up to 90 degrees. Okay? So let's pick, yeah. So there two, that's just an example there. You can pick any example you want. Okay, so as long as they add up to 90, these two numbers here, as long as they add up to 90, okay, you should get the same answer. Okay, so let's do another example. So let's do, just pick two numbers that add up to 90. So 30 and 60. So, if you want to put 30 into cos and 60 into sine, do that. If you want to put 60 into cos and 30 into sine, do that as well. Okay, so I'll go with my first example if I said it first. Sine of 30. Put that in your calculator. I'm doing that. Sine of 30. Make sure it's in, well, just for the principle, I'm going to be doing it in degrees. Sine of 30 in my calculating degree minutes, sorry. Sine of 30, we get a half. Cos of 60, okay, we get a half. Okay, so that's an example there. You can do this as many times as you want. It won't be broken. Let's do the sine of 10 and the cos of 80. Okay, so do the sine of 10, which you get this 0.17. Now that might be a bit more tricky to make it the same. Okay, so it's 0.1736481777, and we'll do the cos of 80. 0.1736481777. Exactly the same. And that's because the angles add up to 90. Okay? So that's a relationship you need to be aware of. Okay? As I say, you can do as many examples as you want, and it will always give the same value. Okay, so hopefully you understand why that is. As I say, it was just a bit of information you need to be aware of, and to be honest, again, it's nothing that they will test on specifically, but I just wanted to highlight what it was about. Okay, so if you do get a question, I think there's a past paper question like that, that is the reason for it. Okay, so thanks for watching, and we'll see you in another video.